So this is an introduction to angles of elevation and depression. This is part of Year 10 Trigonometry. So we can see in the diagrams here that angles of elevation and depression are always measured from the horizontal. So imagine you're staring straight ahead, and then if you have to look up at someone in a hang glider, for example, the angle that you move your head through, that's called the angle of elevation. If you're the person in the hang glider and you were looking straight ahead, then you would be looking down at the person on the ground, and so you would be looking at in an angle of depression. So here is a quick example of drawing in angles of elevation and depression from a worded problem. So a squirrel is at the top of a tree and sees an acorn on the ground 100 meters from the base of the tree. Draw in the angles of depression and elevation. So I am definitely not an artist. Here is our tree. Here is our squirrel. I'm not even going to try. I'm gonna make an S for squirrel, and I'm going to put a little A for the acorn. Okay, now part of these problems is being accurate with what you're labeling with what. So this says the acorn is 100 meters from the base of the tree. So here is the base of the tree. So this is 100 meters. Do not think that it's 100 meters from the squirrel like this. That means you haven't paid attention to the problem. So that is wrong. We'll get rid of that. So here is our base of the tree, and it says what is the angle of depression and elevation. And you can see if we draw up our straight line here, it's not actually going to be a perfect right-angled triangle, and it should be. For any of your problems, you should get a perfect right-angled triangle. I'm just going to move my squirrel over slightly. There we go. Now it works. We're asked now about angles of depression and elevation. So we obviously need to be connecting the squirrel and the acorn. I'll use the ruler for this. So there's our squirrel, there's our acorn. Boop, boop, boop. Okay, so now we have a triangle, which means that we have some angles. So remembering that these are always drawn from the horizontal. There's only one horizontal line in here currently, and that's this one down here at the base. So that angle is going from the horizontal up, right, to the line of sight between them. So this is an angle, we'll just call it theta. This is our angle of elevation. Okay, and then for the squirrel, we need to draw in the horizontal line for the squirrel. It's not there at the moment, so if the squirrel was looking ahead, there's a horizontal line. Oh, there's a horizontal line. And so the squirrel is looking down, so this is an angle of elevation. I'll give it a slightly different symbol. There we go, it's called a sigma. So this is our angle of depression. Now there's something you may notice about these angles. They look pretty similar in size, and they are in fact exactly the same. If you think back to geometry from year 7, when you have two parallel lines and a transversal, so that's a line going through them, if you can make a Z shape here, the angles in the corners of the Zs are equal, and also on the other sides, those two are equal to each other as well. So we have that pattern happening here. We have a Z, and there are the two angles that are the same. So what we'll do for the rest of the video is I will just take you back over here. And I will just get you to read this example. So pause the video and read. We're going to talk about a problem that there is with this. So pause now. All right, the problem with this question is in the diagram here, so you can see here's Monique standing there. You can see she used a clinometer. That's a tool that you hold up to your eye, and you hold the bottom of it horizontal, and then it tells you the angle of elevation or depression to what you're looking at. There's like a little, like a ruler type thing in there. So the issue is, you can see this diagram down here has it as though this squiggly green bit where we've measured our 70 degrees from, as though that's on the ground. So you can measure the height of the building from that. Okay. Whereas you can see in this picture over here, it's got Monique standing, and then the 70-degree angle is up there. Now these are going to be different triangles. Okay. If it's 70 degrees when she's standing, that's going to looking to the top of the building. It's going to be a different angle if it was measured from down here on the ground, right? That's going to be a bigger angle there. So in this question, you have to go, all right, did they tell us her height? Because we'd really need to know her height in order to figure out the height of the building. And it doesn't tell us her height, so we are presuming that Monique is lying down on the ground. Yeah, little stick figure. That she's lying here with the clinometer. Okay, and so you've got a 70-degree angle like you do here. I should probably draw her in over here. There we go. And then your triangle makes sense, and you can do the working as shown over here. So as for all of these problems, you draw the situation very basically. You have a triangle, redraw your triangle. It's just easier to work with. Fill in the information you know, 85 meters from the base, 70-degree angle of elevation, so from the horizontal going up. We want to know the height of the building. That's represented by the opposite side. So then you label your triangle. We've got the opposite that we want to find. We know the adjacent, so we're using tan. Always write your ratio as the first line of working. Fill in what you know, rearrange. That's what's happening in green here. 85, 10, 70 is something you put in your calculator. 2 decimal places and units, and your nice worded answer. All right, example 2. Have a read of example 2. Just pause. All right, we can see here in the diagram we have 2 nice horizontal lines drawn in, and we have an 8-degree angle here, and we are trying to find how far from the base of the tower is the boat. So we're trying to find this X down here, but we have that 8 up there. So you have a couple of options. Remember what we said about alternate angles? Here's your nice Z shape. So this in here is also 8 degrees. Oops, not 80, 8. Okay, so then you have a nice triangle with your right angle. You have one side that you know, your 160. You have X, which you're trying to find, and you have your angle. And then the working is just over here to the right. Your other option with the diagram is to use the triangle with the 8 that's already in it. That line should be extended across a bit more. And just say, well, we know the height of the tower is this. That's the horizontal line. So this is 160 meters, not degrees. So there's your nice right angle. And you're then trying to find the distance from the base, which is the same as the distance across the top. So there's your X. So you can use that triangle to solve, as is happening over here on the right. Another tan problem. All right, last one. Again, have a pause, have a read. Have a go if you like. Okay, so this problem is different. The other problems that we've had are finding unknown lengths. This is a finding unknown angle question. Find the angle of depression. So again, you won't always be given a picture. In fact, you'll often have to make your own picture. Do you have enough information here to draw this picture? No, because you're not told the third. You maybe, but you really shouldn't have to read part B to find out that it's 38 meters tall. Usually that would all be given in the first part. Anyway, so you do have a diagram here. You clearly have some triangles. Here's your depression marked in, the elevation marked in. Redraw the triangles that you need. Recognize which ratio you're going to use. You've got adjacent and opposite, so using tan, remembering that once you get to this step, you're going to take the tan inverse of that ratio. So tan inverse of the ratio is equal to theta, and you can solve like that. I would usually leave the theta on that side, so it would look like theta equals tan inverse of 38 on 50, and then you still have your theta on the left, etc. That's the end.